This is rational expressions, equations, and functions, exploring graphs of rational functions. We're going to be actually looking at the graphs of rational functions and picking out their critical points and asymptotes. And eventually, you're going to have to graph a rational function without technology, but we're going to kind of work backwards to give you an overview. So first of all, the terminology is really important. You had to define a lot of these words prior to this class, so you can fill in these words on your own and make sure you know the definitions of these words, because it's really important when we talk about them that you can identify them in relation to the function and what they mean. So go ahead and do that on your own time. So now what we're going to do is we're going to actually sketch the function, but we're going to use Desmos to help us. So this is the most basic rational function, and all other functions transform from this, 1 over x. So let's identify the restrictions first. Well, the denominator cannot be 0, so x cannot be 0. Well, the restriction is either a hole in the graph or it's a vertical asymptote. In this case, I know that it's a vertical asymptote. That means it's a value that the function approaches but never touches. So this is the equation of the vertical line, x equals 0, and we use a dashed line to show that it's a vertical asymptote. So the domain will take on all values except the number 0, and we could write that using this notation, interval notation. So we already know a lot about it. The graph will go left to right, it'll jump over 0, and then it'll continue on. The x-intercept is found by setting the function equal to 0. And when you cross multiply, notice that the x values cancel out. So that means there is no x-intercept. So the function will never cross the x-axis. Well, if it's never going to cross the x-axis, then I know that it has a horizontal asymptote of y equals 0. And I also know that by just looking at the function, because the degree of the numerator is less than the degree of the denominator. The degree of this is 0 and the degree of this is 1. Remember, the degree is the exponent, the highest exponent for the variable. So the horizontal asymptote is y equals 0. The y-intercept is found when you evaluate the function at f of 0, and that would give you 1 over 0. Well, that's not possible, so there is no y-intercept. And that makes sense because we already know it has a vertical asymptote of x equals 0. So the function is never going to cross the x-axis or the y-axis. Then you could pick some points and just plug them in and see what you get. We know that 0 is undefined. If you put in 1 for x, you'll get 1. If you put in 2, you get 1/2 for y. So I'm just making a table of values. There's infinite number of values you could use. And then we could plot these points and get an idea of the graph. But let's take a look at it if we're looking at Desmos. So this is the equation of y equals 1 over x. Oops, let me go back. And notice that it looks just like what we were doing. What's great is you don't have to actually put in y equals. So here's the vertical asymptote, the horizontal asymptote. The function gets really close to the asymptotes, but it never touches, left and right. Notice here that on this side, the function is below the x-axis. That means it's negative. And the function here is above the x-axis. That means all the outputs are positive. All the outputs here are negative. All the outputs are positive. And that's what you do when you do the sign chart. So let's just sketch our graph. When you guys sketch, you won't have to actually use graph paper. You'll just do a sketch of it, and you'll label really critical points. And you'll do this in calculus. So using a sign chart, which is below, that just basically tells where is the function 0, where is the function undefined, where is the function positive. Everything to the right of the function is right of the 0 is positive. That means everything over here is above the x-axis, and everything to the left of 0 is negative. And notice your outputs are negative, not your inputs, your outputs, and your outputs here are positive. So that just means if it's above or below the x-axis. So I'm going to stop there. I want you to graph the second one, B, and see how much you could do on your own for B, and the next video will entail B.